Okay, well, let's get started. So this is Unlocking the Power of Salesforce Integrations with Confluent, presented by Big Compass and Confluent, of course. And we're going to talk about integration pain points with Salesforce and ways to integrate with Salesforce. And the reason that we're doing this is because we're seeing integrations with Salesforce pop up so much in the industry these days. I know Brian's working with a few customers. Alex is working with a few customers who are integrating with Salesforce. Big Compass is working with quite a few customers integrating with Salesforce. And the same types of problems seem to be popping up over and over and over. And so we want to be able to talk about the ways to integrate with Salesforce to all of you and solving that oftentimes difficult challenge of unlocking Salesforce data and getting that data out of Salesforce so you can power downstream applications. And we'll talk about how you can do that with Confluent, using the power of Confluent. And then we'll talk about a few different use cases for extracting data out of Salesforce using Confluent. And just really quick, I want to introduce myself as well as Big Compass. So I'm Aaron Lieberman. I'm the cloud practice manager here at Big Compass. And so I lead a team of people who are passionate about cloud technologies like Confluent and AWS. And it's the type of technologies that we use to deliver integration as a competitive advantage for our clients. And so I also play an architect role as well for when I'm engaging with clients. And so I architect solutions around using backbones like Confluent for integrations, and I architect solutions around AWS and technologies similar. And Big Compass is a consulting company. We're based in Denver, Colorado, and we specialize in integrations and related technologies. And so those are the technologies, like I mentioned, of course, we're like Confluent, and we are Confluent partners. It really fits well into our ecosystem of technologies because Confluent oftentimes in integrations is used as a backbone for pub sub, and it really is much more than that, which we'll talk about here today. So I'm very excited to be here with Confluent and to be partnered with Confluent because we use it all the time in our integrations, and it's just such a common use case. And here at Big Compass, we focus on building connections, and we build connections between systems and applications. And that's the integration side of things. So we're literally physically creating those connections between different systems and applications for our clients when we engage for certain projects. And we're also building connections between people and ideas also. I arguably think that's even more important, especially now when many people are working remote and might not see people physically day to day. It's even more important to put focus into building connections between people. And that's exactly why we're having this webinar. Would love to reach out to all of you and meet all of you. So don't hesitate to follow Big Compass, follow me, reach out to me, email me, aaron@bigcompass.com to connect. And so let's dive into Salesforce integrations. And by the way, I'm presenting with Alex Wolford. I'll let Alex introduce himself towards about the middle of the presentation here. So let's talk about those Salesforce integrations. And first thing we're going to talk about is integration pain points with Salesforce. And I think it's so interesting because nobody actually talks about pain points of integrating with Salesforce. It's sort of funny. I did a Google search before this, and the Google search was Salesforce integration pain points. And basically nothing returned that was useful to me. The top hit was actually 3 pain points of user engagement when it comes to Salesforce. And we're not talking about user engagement here at all. We're talking about integrating with Salesforce. And then underneath that was how Salesforce solves various pain points for an organization. We're actually talking about quite the opposite, because a lot of times it's very difficult to get that data out of Salesforce and to create those integrations. Oftentimes they're one-off custom integrations. And so if we look at Salesforce from the perspective of integrations, Salesforce is a great tool, but oftentimes it comes with certain pain points. And one of those pain points is subscription tier limits. So you have a lack of features at lower subscription tiers, for example. You have lower API and event limits, especially at those lower subscription tiers as well. And when you're integrating with Salesforce, you have to be aware of these API and event limits so that you don't go beyond them, and you have to stay within the confines of these API and event limits. And you have countless customizations. So I have this on the pain points slide, right? But this can be a benefit to many people. But it's a double-edged sword. Countless customizations can lead to many rabbit holes. It can lead to a lot of custom code. And that's the fourth bullet point here is a lot of custom code can go into creating these triggers to get your data out of Salesforce. And it requires more Salesforce knowledge to create this great amount of customization. And then there's unexpected API security as well. And what I mean by this is that Salesforce's API security is not necessarily industry standard. They use what's called Salesforce tokens. And so, of course, Salesforce ships with all these great features and this custom code with Apex. And so, of course, they also have a custom security model for their APIs too, right? It makes sense. They wanted to be different, I think, than everyone else in the industry. And all of these pain points lead to data locked up in Salesforce. And that's the point here. We want to oftentimes be able to get that data out of Salesforce. And it makes it more difficult than it should be oftentimes to synchronize target systems with Salesforce, which we're going to talk about more here today. And now you can think about two different types of integration methods with Salesforce. And one of those is pulling data out of Salesforce. And the other is creating triggers in Salesforce to push your data and events out of Salesforce. And so the difference between these, number one, pulling typically uses the Salesforce APIs to query data on demand. And that's great for batch or on-demand use cases when you just want to query a quick object on demand, or you want to be able to get all employee records, for example. You can use the Salesforce API to get many records in one request. And it requires very little Salesforce knowledge. Really, all you need to be knowledgeable about is the Salesforce API itself. And the Salesforce API is documented very well. The API itself is actually it's a very good API. And so that Salesforce knowledge is not necessarily required. And so this is a lower complexity. It's a low amount of moving parts. You have your consumer consuming the API. You'll probably do some processing, and you would send that data off to potentially a target system. And now the other mode of integration with Salesforce is pushing data. And pushing data would typically involve you creating triggers. And these triggers would be, for those of you familiar with Salesforce, we'll talk about these more in just a second, push topics, platform events, change data capture, and so on. And you would do that within Salesforce, even potentially using custom code to send events to a subscriber. And this is really good for real-time use cases or event-driven use case. When you have a real-time need, you're probably going to be pushing your events out of Salesforce to accomplish that real-time need rather than querying that on demand. And the skills that it requires is a deeper Salesforce knowledge, because you're going to be creating those triggers within Salesforce. That deeper Salesforce knowledge is required to be able to create those events. You might even need knowledge of Apex code itself if you're creating platform events. And so the complexity is a little bit higher, but you get to accomplish some of those real-time use cases. So the actual ways to integrate with Salesforce now, and these are not all of the ways to integrate with Salesforce, but you can see a nice comparison of the integration methods with Salesforce. And so the integration method of batch aligns really well to pulling data out of Salesforce. And you would create a single request, right, to get many objects in Salesforce, and you would use that Salesforce API to pull these records out of Salesforce. And that's really good to implement a solution for non-real time. If you don't have a near real-time need, then you can use the great Salesforce APIs and pull that data out. But it's not so good for constantly changing data. For constantly changing data, you're probably going to be making a lot of API requests if you were to go down this path, and you might hit those API limits. So for more frequently changing data, you want to go with the real-time integration method. And the real-time integration method aligns pretty closely with creating those triggers within Salesforce, like a platform event or a push topic. And you create those individual events for changes that occur within Salesforce. And Salesforce has an event bus under the hood that it uses to be able to event these out to subscribers or consumers. And this is really great for real-time use cases and handling events individually. So handling events individually also allows you to, for example, create really good error handling around individual events, or have great granular control around your individual events and process them at a business logic level. It eliminates the need for, for example, with a batch, you to sift through all of the records in a potentially very large batch and handle those errors within that batch in a pretty elegant way. And it's not so suitable for less frequently changing data. Now, if you have less frequently changing data, a lot of times you can use the Salesforce APIs, and a lot of times that might be the right path. You might even do a hybrid approach between the batch and real-time integration methods. And then the last two approaches here are Salesforce native. And so if you're familiar with Salesforce, you're probably familiar with the App Exchange. The App Exchange allows you to install out-of-the-box apps in Salesforce that integrate with other systems. For example, like MailChimp. If you want to send off an email campaign, you could integrate out of the box using an app in App Exchange with MailChimp. And that's really good for use cases where you can integrate with common systems like MailChimp, as I said, but there's significant downfalls to that approach. So number one, apps that aren't built yet. You know, we're integrating with so many different varieties of systems that are out there in the marketplace today that just so many apps aren't actually built in the App Exchange yet. And then if you look at, let's use the example of MailChimp. If you look at MailChimp, that app within App Exchange itself typically won't, it might cover 50% of common use cases, very common use cases. But then when you get into the other 50% of your custom use cases that you need to achieve, that app might not actually accomplish what you need to accomplish. And so a typical process flow for somebody making a decision here is always check the App Exchange first, right? Let's see if there's an app out there that does what I need. That is the easiest path to go, and would highly recommend it if there's an app out there that does what you need. But then you make the assessment based on your use cases. Does that app in App Exchange do what I need it to do? And oftentimes it doesn't do what I need it to do if it exists at all, right? So then you start to go down a custom path, and you can start to weigh the benefits, the pros and cons of the real-time versus batch approach. Or for organizations who are all in on Salesforce, you could go with a custom Salesforce UI. And that would be using Lightning Web Components. And you can create that custom UI right in Salesforce. And so if you want all your data in Salesforce, you have no need to get your data out of Salesforce, you could build that UI directly in Salesforce. And of course, you need Salesforce expertise to do this, but for organizations who are bought into Salesforce, why not? You might as well keep that data in Salesforce. But if you need to get that data out of Salesforce, obviously that would not be a feasible option. And I also want to mention external objects are also a great way to integrate with Salesforce. If you're not familiar with external objects, it's a relatively new concept where you can specify a web service to point your objects to an external web service outside of Salesforce, and Salesforce will act like that data lives natively within Salesforce. It'll pull that data in natively and allow you to interact with external objects. So that's not on the screen here, but just another way to another consideration. So unlocking data out of Salesforce is not a trivial task. Getting that data out is difficult oftentimes. And so we've talked about the ways to integrate with Salesforce, but you can already see that there's quite a few considerations for integrating with Salesforce. It's highly customizable, but you're seeing that double-edged sword of, there's so many different ways and I can integrate with Salesforce, and so many different paths that I can take. So oftentimes just choosing one path and sticking with it. And it's necessary to get that data out of Salesforce so often to power your downstream applications. And we'll look at use cases in order to do that. And Salesforce is acting a lot of times as the enterprise's data hub in the modern era. So many different pieces of data are flowing into Salesforce, and you want to be able to get that data out of Salesforce to power other applications. So you first need to answer the question, do I want to pull data out of Salesforce? Do I want to push data out of Salesforce, or go with a hybrid model? And Confluent source and sync connectors can greatly help the speed of integration for getting that data out of Salesforce, which we'll look at here towards the latter half of the presentation. And otherwise, if you're not using a pre-built connector, it takes custom code to integrate with Salesforce. And a lot of times you don't want to go down that path because a custom coding path can take a non-trivial amount of time to be able to create that implementation. So we'll talk more now about the real-time use cases, because that's the way that so many organizations are moving towards. And real-time events, I truly believe, are the next trend. Gone are the days of batch processing. I already talked about batch processing a little bit. Nobody likes to implement a batch process. And real-time events play well with an event-driven architecture and microservices-based approach. And those are the types of systems that we're architecting and creating these days. And they're great architectures for the modern enterprise because you can handle granular, event-level, real-time events as they occur. And so the more that we can deliver real-time data, the better insights we can get, the quicker we can take action, and the more we can unlock the potential of the data running through our systems. So let's talk about eventing out of Salesforce, because this is how you would accomplish now the real-time needs. And so when you want to event out of Salesforce, now there's, again, a few different paths that you can take. Of course, there's options. It's Salesforce, right? So you can take some of these considerations, and under the hood, these events, for the most part, use the Salesforce Event Bus. And the Salesforce Event Bus is a messaging bus that ships with Salesforce. It's under the hood, so that Salesforce can create a pub/sub model and guarantee delivery of these events. And so the first one is platform events. These are custom pub/sub events. It's highly scalable, and this is my recommended way to event out of Salesforce when you have the Salesforce expertise to be able to create these triggers, these types of triggers. And they're created using custom Apex code. And so that's why I say, number one, that they're highly customizable, but that you need that Salesforce knowledge to be able to create great platform events. And it's highly scalable as well. So what you can do with platform events, the beauty of it is you can event out entire objects, you can event out partial objects, you can even aggregate objects based on a particular event. There's a lot of customizing that you can do within these platform events because essentially it is custom code that you're creating under the hood for these types of triggers. And then there's push topics. So push topics allow you to track field changes in Salesforce. And push topics are defined using a SQL query. And it events the results of this SQL query, and it triggers based on the changes you make to an object. And additionally, there's out-of-the-box push topics that can really accelerate your development timeline. So push topics might be a great choice for you if you have a lower Salesforce skill set and you don't mind that you have a lower ability to customize the event. They're very straightforward and easy to implement. The next one is change data capture. And change data capture does almost exactly what it sounds like. It notifies you on changes on an object. Very straightforward to implement. And it publishes new or changed records on an object, and only those new or changed records on an object. So you have a very low ability to customize the event for change data capture because you only get those changed fields on that object. But again, that might be a good use case for you where you only care about those changing fields on a particular object. And then the last one, fairly antiquated. A lot of people are not using outbound events anymore because it's sort of a SOAP style, and nobody really likes SOAP anymore. More people are moving towards REST, and this events out using the SOAP schema, and you can send these outbound events out to a RESTful or SOAP endpoint. But you have that lower ability to customize the event, and who wants to use SOAP these days? So unlocking data out of Salesforce involves a lot of different considerations, a lot of different paths, and this is what it might look like from a very high level. Where Salesforce, you might be creating platform events, right? A publisher. And then you would have a subscribing layer and a processing layer. And in this case, what we're talking about today is how Confluent can subscribe to these types of events. And Alex, I believe, is actually even using push topics. And then you would have a target systems layer. So Confluent can do, some data mashing. It can subscribe to those events, and it can event those out in real time, using streams. It can enrich data to these target systems. And we'll talk about a real-time path as well as a non-real-time path. So your real-time path might involve a socket that hooks into your consumer applications, and your consumer applications can get live updates of data coming from Salesforce. And you might also have a non-real-time path. A non-real-time path would go to a database, and then you might slap an API on top of that database to allow your web and mobile applications to do something like a refresh or a get all employees type of query. And so, of course, with Confluent, you're powering these real-time needs. And so we prefer the real-time sync method, but we also recognize that the non-real-time methods, using APIs, is a very relevant use case for many people. And so let's look at that just in a little bit more detail. So again, you have a publisher from within Salesforce, and now you have your subscriber layer. And what actually happens within Confluent is within Confluent, you can point to Salesforce using a Salesforce source connector. And what that can do is it can subscribe to the events coming out of Salesforce, and it'll get them into a topic within Confluent. And what can happen after that is you might have some KSQL processing. You might put that into a stream. You might do a little bit of processing enrichment. Alex will talk more about that in his demo. And coming out of the tail end of that KSQL processing, it might go to a different topic where you've filtered out events, for example. And coming out of that topic, that can power now your real-time needs. And that can go to your WebSocket, your real-time target, to power your downstream applications. And then also, we're hooking in multiple subscribers here, right? That topic can also go to a database sync connector, like a MongoDB Atlas sync connector, for example, to be able to send that data off to a persistent data store. So you have your data storage target as well. So we're starting to see that, one source can start to event out to multiple locations. And the Salesforce integrations with Confluent come pre-built with a source and sync connector to speed up your integrations. And it makes it really easy to get the data into a tool like Confluent that unlocks processing potential. Because once that data is in Confluent, it's easy to use a pub sub model to process and route the data. I think that's how most people know Kafka Confluent as that pub sub. That's exactly what you can do. You can easily add in new subscribers, but what Confluent does is so much more, right? If you want to be able to scalably event out the database and cold storage and Hadoop and so on and so forth, you can hook into these Kafka topics to easily scale your organization into the future. And you can join from multiple sources as well. So you can use SQL-like queries to join data from multiple different sources, not just Salesforce. And you can stream that data. This is what's powering real time. Your latency is really only as good as your processing power. So you want to be able to stream that data at huge scale to your target systems. And you can also accomplish duplicate detection. This is some of the business logic that we're talking about. You can detect duplicates. You can detect from Salesforce when a lead needs to be converted to an opportunity, for example. And you can run these SQL-like queries to find trends and events of the data that's coming through your Confluent platform. And you can detect those events and take action based on those events. So the whole point here is it's much more than just pub sub, right? Yes, you do have publishers and you do have subscribers, and that allows you to get your data from multiple source systems to multiple target systems, but it's a lot along the way as well. And so one of the use cases that I want to talk about here today and that Alex is going to demo towards the end is data prep. And you can use Confluent as your data stage to prep your data for downstream systems. And this is when you need to enrich data. This is when you need to execute light transformations on data. And if you need to do this from multiple sources of data, like websites and like mobile applications and like Salesforce.com. And this allows you to clean your data, enrich your data, stage your data all in one platform and reliably event that out to your target systems. The next use case is a 360 customer view. Again, Alex will talk about this in his demo. And this allows you to combine data from multiple data sources easily with Confluent, using SQL-like queries on a stream, and enrich your data and send it to a target system of choice with pre-built sync connectors. And so many customers are after a 360 view of what their customers are doing. They want to be able to understand their customers better, right? So this allows you to gain valuable insight about your customers from multiple data sources and combine those into one platform, and to be able to even execute and start even getting into predictive analytics, for example, on, if you detect an event based on what your customers' previous trends were, you can start to take action and gain very rich insights about your customers. And the last use case we're going to talk about, of course, we're talking about Salesforce.com today. So it's synchronizing Salesforce.com data with a target application or multiple target applications. And we're seeing this need come up over and over and over in the industry. And you might even have this need. I'm curious if anyone does. Feel free to reach out if you do. Synchronizing data with the target system, for example, the power of mobile application. I've seen that quite a few times now in the industry. And you might also have to think about two-way data synchronization, made very possible with Confluent using the source and sync connectors. So you can event data from Salesforce to a database, but you might also need to execute updates on the database and have those events flow back into Salesforce, right? And that's very possible with Confluent as well. And you need to also be able to prevent an echo chamber and detect duplicates coming through your system. And the processing power in Confluent allows you to do that. It also allows you to detect business logic and events using the data coming through your topics and your streams. And allows you to do that real-time streaming, allows you to complete that real-time use case that you might have. And so what that might look like, again, from an architecture point of view, is now we're hooking in multiple source systems. The rest of this architecture diagram looks fairly similar in terms of the targets that we're looking at here. But now you can hook in, a web application. You can hook in Salesforce, and Salesforce might use the Confluent Salesforce source connector, and that might hook into its own topic. And the web application might hook into a separate topic, but ultimately those can flow into the same stream. And what you can start to do is join that data up to be able to enrich it, detect events, get your customer 360 view. And so now we're talking about all of the three use cases that I just talked about in one sort of super use case. And now I'm going to pass the mic over to Alex. And Alex will talk, more about this super use case and the use cases I just talked about and dive deeper into Confluent. So, Alex, go ahead. I'm going to stop my share.
Thank you. All right. Thanks ever so much, Aaron. That was great. I'm going to show you some practical examples now of how you can make this stuff work. So, I'm hoping you could let me share my screen. And let's start off by talking about the Strangler Pattern. So the Strangler Pattern is a software design pattern that basically you have some old, tired legacy system. Every business has one. If you go to Costco, you see the AS400 there, and you think, how can Costco run its business on an AS400? And yet have a website and all these other interesting marketing things that it does. And the reason it's able to do that is due to this thing called the Strangler Pattern. It's named after a fig that grows around another life form, and eventually the other life form kind of dies inside it, and you end up with just like a structure made of the fig, the microservices and all the sort of modern things that people want to do. So Confluent enables this by having an ecosystem of connectors. There are, I don't know, about 180 of them almost today, and they'll connect to most things that you come across. They'll change data capture out of SQL databases. We'll show you how to do that in a minute. They can, as Aaron mentioned earlier, we can change data capture out of Salesforce. We'll show you how to do that. There are sources and there are sinks. A source gets data into Kafka and a sink gets data out of Kafka. And so what I want to do is show you a practical example of how you can create events from Salesforce and get them into Kafka. And then once we've got them into Kafka, I'll show you some cool integration patterns and something that I built just last night. And I'm really relieved it's working. So there's this thing called a push topic in Salesforce. Some of you may be aware of this. It's based on a SOQL query. There's a Salesforce object query language. I think that's what SOQL stands for. And basically you have this select statement. You say what you want from one of Salesforce's objects, and you give it a name. And anytime there's a change in this SOQL statement, those changes will get published to a topic, and you can have a connector, which is basically a bunch of properties that will allow you to consume these messages. So this is what I did to create a push topic. And this is what I did to create the connector. We'll share the slides afterwards. If anyone wants to set this up, you can reach out to Aaron or I afterwards. So let's take a look at the what this means in practice, right? So I have Kafka running here. This is a console consumer. So if I run this, this is going to consume all the messages from this Salesforce.com contact updates topic, and I'm going to create a topic. So let me create a contact in here. So I'm going to say, you know, my first name is Silius Sodus, and I am I don't know, a soldier, right? Centurion, how about that? So if I save this and we'll pop over, oh, look at this, it turned up right away. See that? So this is streaming messages from Kafka, and my contact that I created immediately showed up in Kafka, which is super handy because you can layer on automation once it's in Kafka. So now we're going to go and explain what we can now do once we've got these messages into Kafka. So Kafka, when I talk to lesser technical people, they'll say, oh, Kafka, that's pub sub. And it's pub sub, but it's a lot more than just pub sub. So pub sub, this is about 10 years ago. All there was producer consumer. I can produce messages to Kafka, I can take them out. And then people realized that they wanted to do stateful things. They wanted to build streaming applications on top of these topics. And there's a Java framework called Kafka Streams. So it enables you to do filtering, aggregation, joins, those sorts of things, which is great. And but Java's not for everyone, right? And so there's another abstraction layer on top of Kafka Streams, which is KSQLDB, which enables people who just write SQL. They can build stateful streaming applications, combining, filtering, aggregating, joining, without having to write Java code. So these are kind of the layers of abstraction, and what you give up by using, say, a KSQL is you know, as long as you can describe what you want to do in SQL syntax, then you're good. So I would suggest that if you want to build a stateful streaming app, you start off with the simplest thing, which is going to be KSQL, and then you work your way down the stack. You know, you're adding complexity as you go down. So you might be able to knock out your use case very, very quickly in a few lines of SQL. So I want to talk about a customer 360. Aaron mentioned this earlier. Customer 360 is a very, very common thing. And you often get data that comes from different places, right? So you've got a web property. You're going to have a cookie on your web property. You're also going to have some data in Salesforce. Maybe you're going to have a document store. And the data is more valuable when it's combined, and it's more valuable when it's combined in real time. I think of this, if I'm on a website and I'm looking at some products, by the time I've left the website, that's probably irrelevant to me, right? So the timeliness of information is super important. If I'm a bank and I'm monitoring transactions, it's useless to realize, oh, look, my batch job identified some fraud that happened yesterday. You know, that money's gone. That will just help you file an insurance claim or something. That's too late. So the timeliness of data is super, super important. So I'm going to show you how you can take like page views from a website, enrich them on the fly, and build customer profiles out in real time. So I'm using something called Snowplow. And basically I have a blog that no one goes to, as you're about to see. But it's called Wolford.io. And if you go in there, actually, if you were to go there right now, then you would see your pages that you viewed in a moment, hopefully. So what I have here is a tag, a JavaScript tag. Look, I've got all sorts of tags. I added this Snowplow tag. And what this is going to do, it's when someone makes a page request, it's going to drop a cookie so you can track their page views, and it's going to capture a whole bunch of information and send it to Kafka as these clicks happen. So look, I have this snowplow.wolford.io running here, this tracker. So this is where these events are getting published. This is a little like Google Analytics, except it has PII. So it's more versatile. Instead of just getting dashboards and summaries, you can actually figure out who people are. Another thing that I find super compelling about this is if you have someone goes on a website that you drop a cookie, you start to build up this profile of who they are, and then later on, they log in, they register, you've got an email address, then you can associate those two things together. And then you know this email looked at all of these things. That's super powerful and something that you can't really do with Google Analytics, which is why I think, it's worth a look, the Snowplow. So what I've done here, let me go back to my presentation. We've got the browser. It's firing a JavaScript tag. I've got some jobs that are like turning it, basically it comes across as some weird format called thrift, which if you're familiar with it, then good for you, but it's turning it into JSON. I've written a Kafka Streams job. Kafka Streams is going to read from a topic, do something to the data, write it back to a topic. So this is what's happening here. And now let's pop over to Control Center, Confluent Control Center, and we'll have a look at a message. So if I go in here, and a moment ago you saw the Salesforce messages. Let's go to Snowplow and maybe, oh look, someone's been on my blog. Maybe can someone in the audience please go to, yeah, thank you very much. Go to wolford.io. Appreciate that. So let's see. Oh, look, Stevens Point in Wisconsin. I don't know who that is. So anyway, this is an example of us capturing data in real time. And this is an event. Now, inside this, look, we've got a network user ID. This is a sort of unique identity for the user. And we know that this user went to this particular page on the website. That shows kind of intent and interest. So what we want to do is aggregate these things. And last night, I knew this was coming up and I'm a bit disorganized. So I thought, oh, I better make something to show them. So this is what I came up with. A microservice that is going to create these customer profiles from Kafka as these events are coming through and store them in a document store. So this is a little bit of a half-baked idea, but it's working. So there is that. And the fact that you could do it in an evening is also kind of cool, I think. So we've got Kafka, we've got this topic that has page views in it, which you just saw. We have this microservice, which I will show you the sort of end result of this. And maybe we can find the gentleman from Wisconsin. I'm thinking that would be him. Oh, there's lots of page views here. So these are, if I expand this, these are all the page views. Someone went to wolford.io, then they went to streaming joins. You've got timestamps. So you know everywhere that everyone went on this website, you can associate that with the browser. And I actually built something like this in a previous life. For an ad tech company. This is a really common thing to do. So I thought it was like kind of poignant just to show that you can do this kind of fairly easily. And the trick is to get all your events flowing into Kafka. So I don't know if I should pause for questions. Are people able to fire up questions, or should we keep going? Keep going?
Folks can either raise their hands or put a question in Q&A.
Okay, very good. Right, so feel free to stop me if we have questions, but I want to show another very common thing that Aaron touched on when an example might be, I have some information about people and some events that are coming through, and I want to combine those two things as they happen. So this is called a stream table join. And the example that I have here, it's a contrived example, but it like illustrates a very common pattern, right? So you have raw events coming through, you have a relational database, and the cool thing about doing it inside of Kafka and Connect and using KSQL to join these things together is you don't end up re-querying the database, which will annoy your DBAs. So the example that I have here is, and this could be true, right? You've got ailments, people walking into a medical facility with things wrong with them. Everyone's got COVID now. So look, we have a patient ID and we have something that happened to them. And if you have really, really, really good eyesight, you can see that patient number 3 here has COVID and patient number 1 has heel spurs. These are events. So, and those events need some context added to them in order to make sense of them. So the context that we want to add in this case is going to be enrollment start and end dates. So we have this in a relational database. Now there are change data capture connectors for like just about anything you can think of, but out of the box in our like Confluent hub, for example, if you go to hub.confluent.io, you'll see, you know, there's MySQL, there's there's a whole suite of change data capture called Debezium, which I think they're super easy to use and great quality connectors. So look, we've got an ID here. We've got the person's name and an enrollment start and end date. So we want to capture this, and I want to show you how change data capture works very quickly, right? So let's say we missed a patient. We missed, there's a particular world leader who's not in this, and it is, anyone guess? No, Kim Jong-un. Kim Jong-un, right? We forgot to add Kim Jong-un. He's now sort of signed up with our hypothetical hospital, and we need to add him so that we can tell if he's covered, if he's enrolled in a plan. So when he gets diabetes or something and shows up, you know, yeah. So what I want to do is pop over to a console consumer right now. So console consumer is just going to take all these messages from Kafka. So this would be our console consumer for this healthcare topic. So I'm going to separate these two things so you can see when I insert the Kim Jong-un into the database, you're going to see him show up in Kafka. So this is very similar to the other thing we did a moment ago with the Salesforce. We added a contact, it shows up in Kafka. This is the relational database equivalent, right? So I'm going to insert into patient, which that doesn't sound right, but look, we're going to press enter here, and here we go. Kim Jong-un has been inserted into the database, and he showed up in Kafka straight away. So let's go back to this. And I don't want to labor this point too much because we're short on time, but there is a connector, and the connector has lots of properties, and you can do all sorts of amazing things to transform the data using these things called single message transforms. You can write your own if you're into that sort of thing. I wrote one the other day. It's quite easy to write, but look, these are transforms that you can do to manipulate the data as it comes into Kafka or on its way out. Anyway. So this is the overall like topology of what's happening. We have a MySQL database. We've got Debezium capturing the changes. We're writing those into a patient topic. We have a Spring microservice that is running that has ailments going into another topic called ailments. And then we're combining these things together using KSQL DB. So let me show you how that works. So Kafka has topics, and KSQL, you can have streams and tables, and these things are backed by topics. And what we have here, we've defined a table that has a key, right? This table that has the patient ID is the key, and the stream also has a key. And now we've got these two objects. We can create a simple select statement to join them together. So this is look, this is SQL. This is not like any kind of convoluted, hard to understand language. Very, very simple to build this thing out. And let me pop over and I will show you what this looks like in Control Center. So look, we have KSQL DB. If I pop in here, we'll have a look at the ailments coming in. So these are being generated. If I pause here, you can see patient number 5 got diabetes, heart disease, you know, all the chronic xenophobia, all the usual things that people get. And so let's have a look at the, you know, in databases, you can have create table as select. You'll often see analysts do this sort of thing. Well, in Kafka, or KSQL rather, you can do create stream as select. So you have this select statement here, which we saw in the slide, and it's basically just an inner join between these things. And the result is a combination of these things. So if I crack this open, look, oh, what are the odds? Kim Jong-un got diabetes. I was really rooting for that. So yes, Kim Jong-un got diabetes, and the good news for him is he was covered. The event happened between his enrollment start and end dates. So that is kind of an integration pattern. It's real time. It's fairly easy to do, and yeah, that's change data capture and KSQL. Pause for questions, I guess. Anyone, any questions come up?
Alex, question for you that I'm getting here.
Yeah.
Is there balance you want to achieve between processing Confluent versus processing with an ESB that you might interface with using Confluent?
Well, one thing that Confluent or Kafka does very well is fan out. So if I think of like traditional messaging systems, you tend to have queues. You define the subscribers up front. I think I'm answering this question correctly. You're saying, like, when you say ESB, do you mean like a traditional messaging queue? Is that what? Yeah. So
yep.
So a traditional messaging queue doesn't scale as well. You end up with a master and a standby. So Kafka scales out. So you can scale horizontally, and in fact, like if you think about the 4 Commas Club, right? There's this guy called Russ Hanneman from Silicon Valley, if anyone's a fan. He was obsessed with the number of commas that he had, and he had this tequila called Tres Commas. But anyway, in Kafka, we think of the 4 Commas Club. These are people who process 1 trillion messages a day. This is a common thing. So I would say that this fan out is kind of a big deal. And what this does for you, if you think about where Kafka came from, so our CEO, Jay Krebs, CEO of Confluent, a few years back, he wrote a book when he was, well, he came up with this idea when he was coming on a plane. He's looking at, this is LinkedIn, the left is the before, the right is the after. It was really hard to maintain all these point-to-point connections, and you don't want to have a human have to get in the middle of some process and create a new subscriber for a topic or something like that. So he came up with this idea, and look, you can tell how old this is because it says unified log. This was before Kafka even had a name, but the idea was you just write everything to a log. So because Kafka is based on a log, instead of storing separate queues, you store stuff in an append-only log. You have a producing application, and you can have loads of consumers. And usually the network is the constraint there, which is what I was getting to with this fan out thing, right? That means you can just go nuts with it and saturate the network and add nodes, and it's like uber scalable. And I think that's powerful, right? Because it means that as a business, you can say yes to people. Another, like, can I consume this data? Well, I've freed it from my relational database. I don't have to worry about adding more and more consumers to the data. I do want to touch on another point that is kind of unique about Confluent here. And maybe this is too subtle, but I do think it's very, very important. If you're a developer So what happens when you first start with one use case? Everyone starts somewhere, right? And you have an origin, you have Kafka, maybe some logic in the middle, and then you have a destination. And that's use case one. Now, usually the person or people or team who creates the data is not the same as the people who consume the data. And maybe they are in the beginning, but down the line, you start to add on more and more consumers of this data. And then you end up with what I call tight coupling, right? So the producer, if they want to make a change, they're going to break the downstream consumers. And so one thing that I think is a pro tip and very, very highly recommended is to use something called the schema registry. And this allows you to evolve the format, structure of the messages over time without breaking the downstream applications. So I would recommend that you use a file format called, message format called Avro maybe. There's, you could use protobuf or even JSON and use schema registry. But look, if you have forward transitive compatibility mode, you change the producer without breaking the consumers. And I think that's super valuable and something that's often overlooked in the beginning of a project. You're thinking, you start off with JSON, you think, I just need to get this JSON from here to there and change it a bit. But in the end, this pays back over and over and over. So it'll slow you down right in the very beginning, but in the end, it's gonna allow you to go a lot faster. Yeah, thanks a lot, Aaron, that's good. Yeah. Other questions for me or Aaron?
Alex, another one here. Can you explain how Confluent might save money versus a hosted legacy solution that does something similar? And maybe even describe the pay-as-you-go model and then how that might give somebody an ROI.
Yeah, that's a really, so one thing I love about working at Confluent, we created this thing called Confluent Cloud that's super duper easy to use. So when you think about these big data technologies, you start off with a laundry list. I need X number of VMs and complex documentation. And you kind of think like, oh man, life's too short, right? But we have this thing called Confluent Cloud, which is a fully managed solution. And if you want to spin up a Kafka cluster, this is all you have to do. You have an account in Confluent Cloud. You'll say, what type of cluster do I want? So depending on my use case, maybe I want something that, the price scales to 0. I don't put any data in it. I don't pay anything. So that's what a basic cluster is. If I want something dedicated, maybe I've got HIPAA data or something like that. There's strict networking requirements, those sorts of things. Then I could have a dedicated cluster. And then once I've spun up my cluster in whatever cloud provider I like, I can, this is my AWS cluster. Look, all I need to do is pop over to this tab here. I say, oh, what do I need to connect to it? Here's my properties that I use to connect to this cluster. And I just point my clients at it. So I don't get into manage the Kafka cluster business because, that's the wrong place to compete, right? If you're working for a business, unless you're Confluent, your business is probably not Kafka. So don't put time into trying to out Kafka Confluent. That's silly. You should just use the managed service and never look back, in my opinion.
And I'll add to that also, big compasses clients, what we're seeing, a lot of people moving from a legacy system to a cloud solution like Confluent that allows you to pay as you go. Just as Alex said, I think that was almost an underrated point that he made was you can scale down to 0. So you can get your feet wet for $0 essentially, or at a very, very cheap cost. And typically as you build integrations on top of the platform, so on top of Confluent, actually your cost ends up going down. So if you look at, maybe taking a step-by-step approach, yes, you're going to sink some cost in at first, but then over time, your cost is typically going to go quite a bit lower than what it took for a full total cost of ownership around that legacy solution.
Yeah, like the cost of an engineer, right? To hire an engineer who can really manage this, you don't just need one, you need two of them, right? If you're going to self-manage, two engineers who are good at this, that's a big ticket item. So best to, like, if you don't need to, don't. Yeah.
No other questions that I see coming in. Happy to take any other questions. Like I said, feel free to reach out to Alex or myself. I do have an appendix that we'll send out with this presentation of some great links. You know, this is just packed with content, right? All of the Salesforce documentation, the Confluent documentation, so on and so forth. Alex can probably even add a couple things in there about Snowplow. And like I said, don't hesitate to reach out. I was happy to present with Confluent here, and thank you everyone for attending.